How induction cooktops really work. The science of instant heat. Imagine placing a cold pan on a glass stove, turning a dial, and almost instantly, the pan is sizzling hot. But here's the twist. The cooktop itself stays cool to the touch. Magic? Nope. This is brilliant. Everyday physics at work. Welcome to Real World Physics Lab. Today we're diving into the invisible world of induction cooktops, where powerful magnetic fields and electric currents combine to turn up the heat instantly. Let's peek beneath that shiny glass surface. Here's what you'll find. A tightly wound spiral coil, made of copper. When you turn on the cooktop, electricity races through this coil in rapid cycles, creating something amazing. A constantly changing magnetic field. This field is invisible, but it's bursting with energy, swirling just above the stove. But there's a catch. The magic only happens with the right pan. The induction cooktop isn't heating the glass or the air. It's looking for a pan made of metal that responds to magnetic fields, like iron or magnetic stainless steel. That's why aluminum or glass pots don't work. They're invisible to the magnetic field. Now, for the physics. When you place a compatible pan on the cooktop, the magnetic field passes through the metal pan base. This field creates swirling eddy currents inside the pan, turning it into a kind of mini electrical circuit. These currents bounce around inside the metal, and because metal resists the flow a bit, that resistance turns electricity into heat, right inside your pan. Imagine swirling water in a pond. The movement is inside the pond, not outside it. In induction cooking, the swirl is electricity moving in circles, heating the pan itself. What's amazing is the cooktop surface barely warms up. Nearly all the energy is created inside the pan, not lost to the air, and not wasted on the burner surface. Why does this matter in your kitchen? Fast cooking. Because energy is created inside the pan, water boils way faster than on gas or traditional electric stoves. Energy efficient. Less energy wasted. Lower electric bills. Safe. The glass stays cool. Much safer around kids or pets. Let's see this in action. Place a pot of water on an induction stove and on a normal electric stove. The induction boil is faster, sometimes by twice as much. That's real energy savings. Cafe chefs love induction for precise control. Turn the power up or down, and the heat changes instantly. Perfect for delicate recipes. So, every time you cook pasta, fry an egg, or brew coffee on an induction cooktop, you're using powerful laws of physics discovered over a century ago, made practical with modern engineering. That's real-world physics in action. Fast, efficient, and safe. If you loved learning the secret science hiding in your kitchen, subscribe now. We break down the hidden physics behind modern life every week, right here at Real World Physics Lab.